Today we'll start with dimension modeling. So actually, dimension modeling is nothing but like a database, like which is designed to query data from the data warehouse system. Okay. So dimension modeling means like it is a database. It is a database to query data. So for querying data, we use dimension modeling. So in dimension modeling, there are two important concepts, namely fact table and then measures. So like according to Tableau, so what is meant by fact table? So here fact table is nothing but measures, such fact table and dimensions. So fact table is nothing but that corresponds to measures, and the second thing is dimensions. So what do you mean by dimensions and measures? So So in Tableau, like if we open any sheet like this, so the data which is in this blue thing is called as dimensions, and which is in green is called as measures. So to distinguish between dimensions and measures, mostly dimensions are like qualitative things. So qualitative things means like country, province, city, etc. So those can't be measured, right? So like we can't say percentage, like we can't like say the sum of them are like difference like that. So they are like qualitative things, dimensions. And coming to measures, measures are quantitative things. Quantitative things means they are measurable. So if you take delivery hour duration, so you can convert that into seconds by changing the strings, or we can like tell the duration of first 5 employees like that. So that is the major difference between dimensions and measures. So this is the dimension and this is the measure. So dimension is qualitative and measure is quantitative. Dimension is in blue color and measure is in green color. So these three are the main points that you should remember when someone asks about fact table and dimensions. Okay. So fact table means measures, and measures are in green color, and dimensions are in blue color. So dimensions are like qualitative things, and dimensions are like qualitative things, and measures are quantitative things. Okay. So that is the major difference between them. So you can say like dimensions are qualitative things and measures are like their quantitative. And coming to dimensions, they are in blue, color coded in blue, and coming to measures, they are color coded in green. So these are the major things between dimensions and measures. So if someone asks the major difference between dimensions and measures, it's like dimensions are qualitative and dimensions measures are quantitative, and dimensions are color coded in blue while measures are in green. So that's it. And next thing, going to facts. So actually coming to Tableau, there are three types of facts. There are additive facts, semi-additive facts, semi-additive facts, and the third one is non-additive facts. So what do you mean by additive, semi-additive, and non-additive? So coming to first one, additive facts. So to understand this concept of additive, semi-additive, or non-additive, you have to like understand one concept called aggregation. So what do you mean by aggregation? So aggregation is nothing but function. We use some functions like minimum function,
Yeah,
maximum,
maximum.
sum, count, etc. So these are the aggregations. So these all together are known as aggregations. So coming to additive table, it says like, so if you can apply all aggregations on a table, it's known as additive facts. That means if we take a table, so if we can apply all aggregations like minimum, maximum, sum, count, then it's a additive fact table. So it's nothing but if we can apply all aggregations on a table, then it is like additive facts. Coming to so that is additive facts. And like example is like sales. If we take sales or profits, if we take sales, so if we can calculate minimum sales, maximum sales, etc. So this means we are applying all kind of aggregation. So it's like additive facts. So coming to semi additive facts, by its name, so we can't apply all aggregations on a table, so we can apply only some aggregations. So if we can apply only some aggregations on a table, then it's called as a semi-additive facts. So here we can say like discount and bank balance. So these are the examples. So bank balance, we can't say like half bank balance or anything like that, right? So we can apply only some aggregations like minimum, maximum, or depending on the situation. So these are the examples of semi-additive facts. Coming to non-additive facts, no aggregation can be applied. So if no aggregation can be applied, then they are non-additive facts. So these are the major examples. So coming to examples of non-additive facts, we can say like latitudes, longitudes. So latitudes, longitudes are the things we deal in maps. So that thing we'll see in the later classes. So these are the examples of non-additive facts. So if someone asks you about facts, like there are like three types of facts. They are additive, semi-additive, and non-additive. So semi-additive, like additive means we can apply all aggregations. Semi-additive only some aggregations, and non-additive we can't apply any type of aggregation. Yeah. So yeah, like the next thing. So you are aware of like primary key and foreign key, right? In SQL.
Yeah, just give.
Yeah. So we use that also here. So we'll just say like definition and then leave. So like primary key, as you know, like it's a key that is uniquely identify each record in the table. So which contain only
And
values and should not contain null values, right? Primary key. Hello.
yeah,
Yeah. So I'm telling like primary key means like it is a key that uniquely identifies each record in the table, and like that it should contain only unique values but should not contain any null values. So that is the primary responsibility of a unique key. So it identifies that the table contains only unique values and should not contain null values. So coming to the next thing, foreign key. So it's an attribute that which establishes a relationship between two tables, right? So it's a field in one table that refers to primary key and other table. So that is the foreign key. So just we are dealing with definitions only. So when we use it in while visualization, then I will explain you. Okay. So these are not much used, but these are used when they give unstructured data and we have to create tables or anything and joining tables, then this comes into play. So as told before, like it's an attribute that establishes relation between two tables, that establishes relation between. Okay, so like foreign key means that it's like a one column name in a table that refers to other table, right? So there will be common names similar. So this thing we can say like it is a field in one table that refers to primary key in the other table. So this is meant by foreign key. This is about much about primary key and foreign key. Okay. Fact table, like they are joined by two dimension tables. Okay, like previously we discussed about dimensions, right? So coming to Tableau, there are like 9 different types of dimensions. So we'll discuss like each of them briefly. So coming to different types of dimensions, the first one is like slowly changing dimension. Slowly changing dimension. And the second one is rapidly changing dimension. Rapidly changing dimension. And the next one is unchanged dimension. Unchanged dimension. And the next one is shrunken dimension. So first two classes, like it will be more theory only. So if we complete this, then we can jump into practical. So these things they will ask like definition interview. So I'm like noting down. So you can also meanwhile note down or just take a screenshot. The next one is conformer dimension. And the next one is like degenerated dimension. And the next one is like informal dimension. Infrared dimension. Infrared dimension. So these are the 8 types. Another thing, role playing dimension. So these are the 9 different types of dimensions available in Tableau. So we'll go one by one. So coming to slowly changing dimension. So this slowly changing dimension, like it's called as, in short form, it's like called as SCD. So what is the advantage is here, like if the data in the dimension, like if it is slowly changing over a period of time. So if the data is slowly changing over a period of time. So if a data is slowly changing over a period of time, that type of dimension is called as slowly changing dimension. So for this example, so currently, like if you take Hyderabad city, so you are living in somewhere called Kukatpalli. So after some time, like 3 months or 4 months, you are changing to other location, which is called as Amirpet. So here, what is the thing happening? The thing happening here is address change. So in a short span of 4 months only, the address change is happening. So that is nothing but here the address is slowly changing over a period of time. So in a less period of time, the address is changing. So this is one of the examples of slowly changing dimension. So coming to next type of dimension, rapidly changing dimension. So rapidly changing dimension means data in the table, like it changes rapidly. So if you take data in a database, so it will be changing monthly, frequently, like monthly, daily, weekly, right? So that comes under rapidly changing dimension. And the next thing is like unchanged dimension. Unchanged dimension is like the data in a table doesn't change forever, so it lasts forever. So that type of dimension will be unchanged dimension. And next thing is like a shrunken dimension. So shrunken dimension is that in which one dimension is a subset of other dimension. Okay, so shrunken dimension is nothing but where one dimension is a subset of other dimension. So if we take like day, so after day it will be week, right? Then month, then year, etc. So here actually if we take day and week, day is a subset of week. So one dimension is a subset of other dimension. So from week we can break down into days, from month we can break down into weeks, year can be break down into months. So if you take a week, it can be break down like 7 days, month 4 weeks, year 12 months, or year can be break down into like 4 into 12, 48 weeks, and days 365 days or 366 days. So this is nothing but one dimension is a subset of other dimension. So this type of dimension is called as a shrunken dimension. So the next thing is junk dimension. So junk dimension is nothing but like a junk food. So it's nothing but like it contains unwanted data. So if a table contains unwanted data like different unrelated attributes, avoid having large number of foreign, like if it contain a lot of unwanted data, that is simply called as a junk dimension. Unwanted data, then it is called as a junk dimension. And the next thing is conformed dimension. Conformed dimension is nothing but a dimension that is used in multiple locations. So if a dimension is used in multiple locations, then that type of dimension is called as a conformed dimension. So this type of dimension, it can be used in multiple fact tables. So this dimension can be used in multiple fact tables, and this is called as a conformed dimension. So to explain it more clear, so we will using the same column in different table like that. So that is like conformed dimension. And coming to degenerated dimension. So in this type of dimension, a dimension key in fact table that does not have its own dimension table. So like the thing is a dimension key in a fact table that does not have its own dimension table. So this is called as a degenerated dimension. So a dimension which is stored in the fact table and has no associated dimension table. So it doesn't have any table associated. Okay, no table associated. So like mostly in interviews or anything, they will be asking like these four only mostly, but it's good to know what is what. So the next thing is like infrared dimension. So coming to infrared dimension is nothing but like sometimes like data referencing a particular number arrives before the member has arrived. So to explain this clearly, like yeah, if you take some like sales transaction field that can like reference a person that does not exist in the base location. So if you take some sale transaction field like that refers a person, but it is not present in the base location itself. So that's, so what is the reason, like it is not present in the base location, but it is present in the sales transaction. Why? Because it is arriving lately. So other name of this infrared dimension is like late arriving dimension. Late arriving dimension. So if you take some table, like if the sales transaction field is available, but though that reference is not available in the base table itself because it arrived lately. So infrared dimension is also called as late arriving dimension. And role playing dimension. So role playing dimension is nothing but like a single physical dimension that can be referenced multiple times. So single physical dimension referenced multiple times. So like these are the major types of dimensions. So mostly they will be asking about slow SCD, rapidly, unchanged, and shrunken. So these are also good to know. So you have, it's better to remember all the 9 types at least. So these are the types of dimensions used. And then the next thing, So you are so you are aware of schemas, right? In SQL also we use schemas.
Yeah.
So in Tableau there are like three types of schemas, like star schema, snowflake schema, and mixed schema. So coming to the first one, star schema. So what do you mean by star schema? Like this star schema, its structure resembles a star. So its structure resembles a star. So it's called as a star schema. And the next thing is like the center of the star can have one fact table surrounded by multiple dimension tables. So if center of chart has one fact table surrounded by multiple dimension tables, then it is called as star schema. Coming to snowflake schema, yeah. And coming to snowflake schema, like if one fact table is surrounded by multiple dimension tables, and in turn they are surrounded by other dimension tables. So in star schema, only fact table is surrounded by multiple dimension tables. That's it. So when coming to snowflake schema, additionally, one fact table is surrounded by multiple dimension tables, and which in turn are surrounded by other dimension tables. So this is like the major difference between star schema and snowflake schema. So here we can say like yeah, one second. Yeah, hi. Yeah. Yeah, so here we can select center of the start. Multiple dimension tables. So here in the snowflake schema also the same thing. One fact table surrounded by multiple dimension tables, which in
Tap for other dimensions.
like these things we don't use practically inside Tableau, but these are just definitions. So I'm just telling like definitions only. In SQL only will create schema and all, right? So here
Yeah.
no need, but just need to identify if tables are given in this pattern. So just identifying if it's which type of schema. That's it. So coming to mixed schema, like it's a combination of star and snowflake schema. So that's it. And more and other question is like they will ask like what is the schema which is used in your project. So mostly snowflake schema is only used in agile methodology. So that thing you can remember. So yeah, this is much about. So coming to mixed schema, like it's a combination. The combination of star and okay. So the next thing is like data types. So this is also like some important. So data types. Coming to data types in Tableau. So Tableau has 7 data types. First one is numerical decimal. The next one is numerical whole. Numerical whole. And the next one is date and time. And the next one is date. The next is string, boolean, and geographical. So these are the 7 types of data types. Like these are the 7 types of data types used in Tableau. So coming to like numerical decimal, like it's take some whole like decimal numbers like points, so 0 0.2, 3.4, like that. Whole means it consider whole numbers. And date and time, it's like date and time format, then date, then string means ABC values, and coming to boolean values like true or false, and geographical. This geographical is used while creating maps. Okay, so these are the major seven types of data types which are used in Tableau.